My name is Greg Stearns. Our topic was system probability. So there's two basic concepts that you need to understand in order to solve problems, and that's the union and the intersection. So first I'll start with the union. You can interpret the union as or, quote unquote, and that's the probability of event A or event B happening. So in order to calculate that, you add your given probabilities, that's the full circle of each one, and then subtract the overlap. This overlap is also called the intersection, which brings to our second concept. In order to calculate the intersection, you just multiply the probabilities given of the two events. Further, to calculate the intersection between three events, events A, B, and C, multiply probability of A, probability of C, of B, probability of C, just like we did up here. And to calculate the union between all three, we add the probability of each one together, as we did here. We subtract each one of the overlaps from two pairs, so AB, AC, and BC, as shown here. And then once we've subtracted those, we still need to account for this tiny centerpiece, which we calculated up here, so you add back that component.
Hi, I'm Josh, and we're going to be doing an example of what we learned today. So today's example is basically what's the probability of Greg actually getting to class. So we're starting from bed, and then we're ending at class. So A is his alarm waking up, and from there he can go. He can either walk, bus, or drive to class, or he can be awake in class. So he can be woken up, maybe he slept there, his alarm woke him up, and he's already in class, which is a very slight chance, 0.001. We're going to start by calculating the probability of R1, R2, R3, which is walking, busing, driving. For R1 to succeed, for him to get to class by walking, he has to B, not break his ankles, and C, not get lost. So that's 0.6 probability of happening and then 0.6 probability of happening. And you multiply those together to get 0.36. For busing, D and E have to occur. D is the engine not breaking down, and E is the tires not popping. So we get 0.5 times 0.7, which is 0.35. And all it takes for Greg to actually drive to class is not locking his keys in his room, which is F, and there's a 0.8 chance of that happening. So we have all of these, and we want to calculate the overlapping areas because we don't want to count stuff twice. So we have the intersection of R1 and R2, R1 and R3, R2 and R3, which we do by multiplying them to each other. So you get 0.126, 0.288, and 0.28. And we want, since we cut all of those out, we also want the intersection of all three of them together, which is R1 and R2, R3, R1 and R2 and R3 together. So we multiply those together, 0.36 times 0.35 times 0.8, which we get 0.1008. And we want the union of R1, 2, and R3 because we want him to get to class, so he can walk, or he can take the bus, or he can drive. So we add these probabilities together, subtract the overlapping areas, and we add the little area in the middle that we subtracted out, and we get 0.9168. So 0.1968 is the probability of him waking up from the alarm and taking transportation and getting to class. But we have our, that's the probability of him actually getting there by transportation. We can't forget that he has to first wake up from his alarm. So we do the intersection of A and R1, R2, and R3, in which we just multiply 0.9168 times 0.9, and you get 0.82512. There's also the option of him just waking up to class. Maybe he slept in class, 0.001 chance. So it can be T1, which is him waking up and then taking transportation, or T2, the alarm going off and he's already in class. So this or this can happen. So we want a union of those two in which we multiply, or we add these two together, 0.82512, plus these two events happening, which is 0.9 times 0.001, and then we subtract the union of the intersection of those two, and we get a final answer of 0.825277. So Greg has an 83% chance that he'll show up to class. Then we want to calculate the different probabilities of events happening within those three R's. So